Hey everyone, Mr. Canistero here. So today we're going to do some F equals ma problems where we're not specifically given numbers, but we want to figure out what happens to the acceleration if we change the force or the mass. So if you remember Newton's second law, F net equals ma, we know that if we solve it for a, so if I divide over by m, a equals the force divided by the mass. What Newton's second law said is that the force and the acceleration are directly proportional, and that the mass and the acceleration are inversely proportional. So what that means is if we increase the force, it'll cause an increase in the acceleration. And if we decrease the, I'm sorry, if we increase the mass, it will decrease the acceleration. So what we're going to find out today is by how much or by what factor, if you increase the mass or the force or decrease the mass of the force, will affect the acceleration. So what we're going to do is we're going to do the first one. What happens if you double the force? So what you do for these problems is you write down your starting equation, so F equals ma, and then you solve it for the variable you're looking for. So in this case, it's A equals force divided by mass. And now what we do is we see what happens if you double the force. Well, if you double the force, it's like having 2F. And then if we have just the force being doubled, the mass stays the same, so that's like multiplying by 1. And what we see is whatever this piece comes out to be is what happens to the acceleration. So if we have 2 divided by 1, we see that the acceleration gets doubled. Okay? Well, what happens if we double the mass and keep the force the same? Again, I'm going to write A equals force divided by mass. And now this time, I'm going to double my mass, and I'm going to keep my force the same. And you see the acceleration gets reduced by a factor of 1/2. Next, we're going to double the force and we're going to double the mass. So this time I'm going to write, again, A equals force divided by mass. And on this occasion, the force gets doubled and the mass gets doubled. And as you can tell, those two cancel out. And what happens here is the acceleration stays exactly the same. So the acceleration stays the same when you double the force and when you double the mass. Our last problem is if we triple the mass and we cut the force in half. So again, I'm going to write acceleration equals force divided by mass. This time, I've tripled the mass, so that's like multiplying by 3, and I've cut the force in half. So what you see here is we end up having a complex fraction. So at this point, you can either type it into your calculator, or you can say, a complex fraction, I can just solve that by saying 1/2 divided by 3 is like saying 1 over 6. And so what you'd find is the acceleration gets reduced by a factor of 1/6. So you see, for solving these problems, it's just a matter of solving for the variable and then just plugging in whatever factor the number multiplies. So for example, if the force gets cut in half, we just multiply F by 1/2 and just see what happens to A. All right, thanks a lot. Hope this helps you out.